One reading makes it evident that it's a set on set theory. 3 sets. So the data given here is such that you might be tempted to use variables, but the way that I'm going to explain is without any variables. There are 2 reasons to that. One, it is obviously going to be faster than writing variables and solving equations. Second, this is practice right now, right? So in practice, you need to sharpen your mind. Be able to do a lot of if-then analysis orally if you want to build speed, that is. So that is the objective. Keep observing how we can manage that. So there are 3 sports and one of them is Gilli Danda, G, other is Kho-Kho, one is Ludo. There are 39 students, each of which prefer at least one of the sports. So this is going to be the union, the 39, all of it. The following details are known. Number of students enrolled only in L. So we are talking about this exclusive region is double the numbers in all 3. So it's too easy a relation. So this is double of that. So if that is X, this is 2X. Okay. There are a total of 17 students enrolled in G. So now this is G is 17. So here is the first input students. Most of us focus on the circle of 17, but there's something more. We already know the union is 39. So the difference 17 to 39 is 22. 22 is going to be these 3 regions. 1, 2 and 3. These are 22. So focus on the other one, right? It is almost always many question setters use that as a trick to make the question tough. The number of students enrolled only in G. So this exclusive region is 1 less than the number enrolled only in L. So this is related to this also. This is related to here. We know the sum of this. The number of students enrolled only in K, the exclusive region, the third one, is equal to those who enrolled in both K and L. So K and L. So this number here is equal to both of these. So this circle, this is X, this together is X, whatever it is, okay. So and the sum is known, so on. So right now you might be tempted, nothing is being filled up and so on, but it's easy, not many clues. Let's read the end. The maximum number of students are in L. So this obviously is going to help us eliminate cases at the end. This should become the highest. Finally, we have a number, 10 students enrolled in G are also enrolled in at least one more sports. So out of these 17, 10 are in at least one more or even in 2 more, right? So 10 are going to be here. So that means this is 7. And now that you know this is 7, this is going to be 8 as per the third one. In G, only in G is 1 less than only in L. So this becomes 8. If this is 8, this is double of this. So this becomes 4. So see how quickly things could unravel, right? And here also you know that the sum of this is 22. Oh, so you already know this is 8. So the sum of these two has to be 14. Right? 14 and 8 is 22. And you also know that this is equal to this plus this. The numbers of students who are enrolled only in K is equal to this. So if this is X plus 4 and the 2 together is 14. So X plus 4 is 14. It's a simple enough. Try to do it in your mind. 2x is equal to 10, x is equal to 5. Oh, so this is 5 and this is going to be 5 plus 4, 9. Check the sum, is it 22? I'll leave that for you. Okay, and 22 and 17 is 39. So we have got the whole numbers. We have used this, all of it is used. The maximum is left. Okay, so let's see how do we do the maximum. Now, we know out of 17, 7 is here. 10 have to be in these 3 regions, of which 4 are identified. So these are 6. So note that the 2 unknown regions as of now are 6. Together they are 6. Now, how do you distribute the 6 such that L has the maximum? So pay attention, students. I am doing it orally and you should manage it. You compare L, let's say with G. Start one way. Now, when you compare with G, this region here, L and G, is present in both G and L. So that is common. I need L to be more. So I look at the other region. So this is 8 and 5, 13. So this sum should be less than 13. This is 7, so this has to be less than 6. So if you're going to forget it, you could put it down. This is going to be less than 6. But then, yeah, it was pretty obvious also. Na? The sum is 6. Oh, 6, 0 is not allowed. Okay, 6, 0. Because if this is 6, this will become 13. This is going to become 13. Then L will be equal to G 17. Okay, so that won't help. So if that is 6, this is 0, 13 and 4, 17. 17, 17 doesn't work. Okay, less than 6. Okay, good enough. Next, compare L with K. The same idea now. This common 9, they are present in K also and in L also. So ignore them. I want L to be more than K. So look at the other regions. And now look, it's different. Earlier you had 8 plus 5, 13 easy. Now you don't have this. You don't have this sum either. So this region is 1 less. But overall, I want this region to be more than the other one. So this unknown one has to be at least 2 more than that. Why at least 2? 1 to compensate for this. This currently is 1 less. So it has to come up to its level and go 1 beyond. So this number has to be at least 2 more than that number. So this is what I mean. Learn logic. And may not be in this set, but will help you some other sets for sure. Let's move to the next step. Now, how do you manage this number being at least 2 more than that? You know the sum is 6. Divide them equally. Start with an easy position. Divide them equally, 3 and 3. It's not allowed. This should be 2 more than that. So that has to be reduced. This will go up. So from 3, I can reduce that to 2. This will go up to 4, and is the difference 2? Yes. So this is 2, this is 4 is allowed. And then this will reduce by 1, this will increase, this will become 5. Here also it's okay, this will become even bigger. And then this could be 0 or this could be 6. So these many cases are there, and you want to see the total numbers. Let's see. So 9 and 9, 18. 18, and depending on this case, K would be equal to either 20 or 19 or 18, depending on this. How about L? 9 and 8, 17, 17 and 4, 21 or 22 or 23. Even if you take the first case, this is 20 and this is 21. Isn't L maximum? Pretty much, right? So depending upon 3 cases we have, and it's very characteristics of CAT to have a little multiple possibilities. Let's go to the question. What is the minimum number of students in both G and L, but not in K? Only G and L. So if I look at G and L, only G and L without K. So that's 4, 5, 6. The question is asking us minimum number. So that is a direct 4 is the answer. This was a ridiculous question. If the number of students enrolled in K and in L are in the ratio. So one set is those who are enrolled in K, one set is those who are enrolled in L. So the entire K and the entire L, they are in this ratio 19 and 22. Then what is the number of students enrolled in L? Now the problem here, or the oversight by the question setter, was, do we know that the union is only 39 people? And this is in the lowest reduced form. So if this becomes 11, this is going to become what? 9.5. It's not possible. You can't have decimal number of people, right? So these not any 2 natural numbers in the ratio 19 and 22 will be either 19 and 22 or multiples of 19 and 22, 38 and 44. Or 57 and 66. Now, how will 44, 66 fit in into 29 people, 39 people? So, the numbers are only 19 and 22. And how many are enrolled in L? This 22 direct. So, this has nothing to do here because of, I think so, he just missed it, the question setter, right? Anyways, if we go back, K and we are talking of K and L. K and L are going to be these numbers, either 20 and 21 or 19 and 22 or 18 and 23. So 19 and 22 is the case, the middle case for this case, right? So that is 22. Now, for third and fourth question, there's some very interesting data here, students, and some amazing learning if you can manage it, students. So pay attention. Due to academic pressure, students who were enrolled in all the three sports were asked to withdraw from one of the three. So currently they play all three, leave out one, so they'll end up playing 2-2. You should know which region, right? Now, after the withdrawal, the number of students enrolled in G was 6 less than that in L, while the number of students enrolled in K went down by 1. Now, this is a direct data. The numbers in K went down by 1. This is a little more tricky data because enrolled in G was 6 less than L. So here you are comparing G and L. Here you are just saying whatever is in K, 1 less than that. So pay attention, students. Some very interesting part, students. Yeah. So pay. So in a smaller one, if I have G, this is G, this is K, and this is L. Now, the number of people here, so these are the ones who are asked to withdraw from one sport. Now they'll end up in 2. So let's say this number A people end up over here from this group. So do you know which sport have they quit? They have quit L. They are earlier playing G and K and L, and now they have gone into the set of G and K. So they are playing only G and K. L has been moved out. Similarly, if there are B people who go here, from here to here if B people go, this B are the number of people who have dropped G, who have quit playing gilli danda. And if C people go over here, these C are the number of people who have quit playing kho-kho. They still continue to play G and L. So I want you to realize that this number here is A plus B plus C, all the three people put together. They were playing all three games. Now pay attention, there's still something more. One part you must have got it, the other. Out of these A, B, C, do you know the movement of A and C have not affected the G circle? They were earlier also in the G circle. Now also they are in the G circle. So G circle has only gone down by B, the one which went out of the circle. Similarly, A, B and C are within L. So the complete L circle has gone down only by A, the one who have dropped playing L. And K has gone down by C. And therefore I said this data immediately gives us a thought. So let's go to pick. We don't need all the details. So the previous one, if we had G, if you remember, G was 17. We had 4 people over here, okay, and we had K and L. And to just get the numbers back, 2019-18, this could have been 2019 or 18. And L could be 21, 22, 23, 21 or 22 or 23, right? Now we don't need these intermediate details. Yeah, when needed we'll come back and refer to this, but pay attention here before we lose focus. Now K numbers went down by 1. So out of these 4, one person has definitely shifted here. One person has shifted here. So that leaves out 3 more. So out of the 3, some person will go here and someone will go here. Whoever goes here, so let's say this is X, this will decrease by X, and if this is Y, this will decrease by Y. The whole G. And why am I interested in this G and L? Because after the withdrawal, G is 6 less than L. So let's take G and let's take L, and the original values, G is 17, L is one of these 2, one of these 3 rather, right? Now let's take X as 0, so Y will be 3. And remember, X, Y, I am just representing here. I am not using them as a true variable sense in the sense of forming an equation and so on. Just to explain, I am saying. You could also have said 0 went over there. So if 0 went over there, do you know that L is going to remain 21, 22 or 23. And if 3 went here, this is going to become 14. Now tell me, is a difference of 6 possible between G and L? If G has to be 6 less, then L should have been 20, which is not possible. So this situation did not occur. Similarly, if X was 1, then Y would have been 2. If 1 left L, then L would have become either 20 or 21 or 22. Then 2 would have dropped here, so G would have become 15. And is a difference of 6 possible, students? 15 and 6 is 21. Yes, 21 is possible. Okay, we can always come down to how 21 it is. When originally it was 22, what values would make it 22? We can refer back. But continue. If two people left L, then L would have been 19 or 20 or 21. And if 2 people left L, one would leave G and G would have become 16. Is a difference of 6 possible? 16 and 6 should make it 22. There's no 22. So this is also not possible. And if all 3 people had left L, L would have been only 18 or 19 or 20, whereas this would remain 17. No one has left G. So is a difference of 6 possible in these 2 numbers? No. So these are not possible, these 3 cases. Oops. So these 3 cases are not possible. This is the only case, and that too with 21 only. And what has happened? Remember, one person has dropped L, 2 people have dropped G. Okay, so this number we could easily say is, what did we have? One person has dropped L and 2 people have dropped this. This has been the shift. Okay, and then the cases, this middle case was possible. So I'm ruling these out. Okay. Are we done? The middle one, and I'll just borrow these numbers from here. 7, 9 and 8 are not affected. So 7, 9 and 8 are not affected. And what did we have in between? Since we are taking the middle case, this was 1 and 5. Okay. So this was originally 1 was here. And this was 5 and this became this, and here we had, what did we have? We had 5 already and 2 have come here. How do I know 5? 5 plus 4, 9. Yeah, remember. So this is how it happened. You can check the numbers again, right? Because 1 dropped in, this changed from 22 to 21 and this became 0 now. Okay, this became 21, and because 1 has come, or 1 went there, 2 went here, so this has become 15. Go back and check, is the difference 16 and 21 this? Do your numbers, students. Run it out in your own mind. It is possible. You do not need to write so much. Yeah, it should have happened with just thinking if then. If then in your mind, it can happen. Anyways, to answer the question, let me move this out. After the withdrawal, how many students were enrolled in both G and K? Both G and K. Originally 1 and 1 more came in. That's 2 is the answer here. After withdrawal, how many were enrolled in both G and L? G and L. Remember, this is 0. G and L are only these. There are 6 in numbers.